Hi guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraj, and in this video we'll be having a look at how we resolve forces. So I am back after a while, but hopefully, as the saying goes, I am back with a bang. So without further ado, let us begin. Now, resolution of forces is not a topic on its own. It's more like a subtopic or a tool that you should have or master in order to solve problems, and it's mostly in physics when you're asked to resolve forces to either get a resultant force or to find unknown forces or angles when a system is in equilibrium. And it's also under a certain aspect of mathematics. It falls under mechanics of math, where you're also asked to do similar, find resultant forces and find unknown forces in an equilibrium system. So all of that requires the knowledge of resolving forces. But what exactly is the resolution of forces? So we're just going to have a look at the basics of that. Let's say, for example, I have a force of 5 newtons going in that direction. Now, resolving forces is in two parts. Either you resolve it to the vertical, that is the y direction, or you resolve it to the horizontal, which is the x direction. So if I just draw, let's say, a broken line to represent my horizontal, and then I draw a vertical line here to represent my vertical, you can see that the 5 Newton force is somewhere in between. Now, in order to resolve this, you need to know an angle, and in most cases they will give you an angle. The question, if they don't, then that's perhaps most likely what you're trying to find for, and they would give you the other necessary information. But for example, let's say the angle over here was 30 degrees, and I want to resolve this 5 Newton force to the horizontal. In order to resolve this to the horizontal, I would do 5 cos 30 degrees. Make sure your calculator is in degrees when you're doing this, because the angle is given in degrees. If it was in radians, then you would have done it in radians. Now, why cos 30? That's what you're wondering probably. There's a certain norm that goes with resolution of forces, and that's when you're closing an angle, when you're closing, you use cos, and when you're opening an angle, you use sine. Now, we used cos here. That means we're closing the angle, and if you look at it, it does make sense. This whole force of 5 Newton, we're trying to get it down to the horizontal. We're trying to find it in that direction. And in order to do that, this 30-degree angle is being closed down. It's being chopped down. So we're closing that 30-degree angle. Hence, we use 5 cos 30. The reason people tend to remember this norm is because of the C of the close and the C of the cos sound alike. So it just sticks to the mind. And then obviously the other one is opening, which is sine. Now, if I wanted to resolve this to the vertical, that means if I want to find the force of this 5 newtons in the vertical direction, then I would do 5 sine 30. Because this very angle that I had over here of 30 degrees, I'm opening it up. I'm taking this guy and I'm trying to get it to the vertical. So this 30 degrees that's over here is being increased and it's being opened up. Hence we use 5 sine 30. Now, what many of you must be thinking right now, let me just draw this again. So I have 5 newtons here. I have my broken horizontal, my broken vertical. In that example, I said this is 30 degrees. Of course, if that's 30 degrees, then this means this is 60 degrees, because all of this is a right angle, and 90 minus 30 gives 60. If I want to resolve this to the vertical, what I could also do is 5 cos 60. Take it like this and do 5 cos 60, which is the absolute same as 5 sine 30. And again, it makes complete sense, because this 5 Newton force you have over here, you're trying to close the 60 degree down, trying to stomp on it, so you're getting 5 cos 60. And likewise, to resolve it to the horizontal, you would open that 60 up, and you would then have 5 sine of 60, which is the exact same as 5 cos 30. And this leads to another norm in trigonometry, basically, since we are using cos and sine here, is that you can have something like this, for example. Sine of, let's say, x is the same as the cos of 90 minus that x. So for example, if I have sine 40, this should be the same as cos 90 minus 40, which is cos 50. And if you use a calculator, sine 40 gives you 0.64 to 2 dp, and cos 50 gives you the same. So that's another norm that's followed, or rather it is a fact because you can prove it. So that's basically the fundamentals of resolving forces. Now let's go ahead into our first example. Okay, I have this example here. I have 4 newtons acting at an angle of 33 degrees to the horizontal. So if I want to resolve this to the vertical, this would be 4 sine 33, because I'm opening the angle up, I'm opening it up. And if I want to, just for the vertical, and if I want to resolve to the horizontal, I would have 4 cos 33. And again, depending on your example, you could leave your answer in direct, exact form, or you could take it to 2 dp or 3 sf, depending on the question. One thing to note, however, because I said there are 2 ways of doing this. For example, for the vertical, I could do 4 sine 33, or I could do 4 cos of 90 minus 33, which is 57. Yeah, this would be 57. 4 cos 57. Now, which one do you do? I believe you should always do the one that involves the angle that's given. In this case, they gave us 33, so make sure that whatever method you're using, or whichever answer form you're using, has 33 in it. The 57 you got is absolutely correct, but derived from the fact that 90 minus 33 would give you that angle. And the questions sometimes don't want you to manipulate the angles in them. They want to see how you would solve it with what you have. And in this case, you have 33 degrees. So in short, I personally recommend that you use the answer form that has that particular angle in it. So in this case, not this. It's absolutely correct. If the exam board doesn't have a problem with it, go ahead and use it. But I would recommend using the one that has that angle. So 4 sine 33 or 4 cos 33. Right, the next one, I have 2 angles, and I don't have it marked with any particular magnitude, so let me just give it a magnitude right now. Let's say this is 6 newtons, and let's say this is 4 newtons. So I have 6 newton here and 4 newton here. Now I'm asked to find the resultant force and the resultant direction that these 2 forces will produce. Now, the way you solve this is, first of all, you decide on a direction. Because direction is involved, I usually say that my right side is positive and my left side, going left, is negative. Likewise, going up is positive and going down is negative. After this, you now start the resolution of forces. So let's first resolve both these forces to the horizontal. Let's start with the 6 newton one. If I resolve 6 newtons to the horizontal, I get 6 cos 45. And if I resolve this guy to the horizontal, I get 4 cos 75. Now my 6 cos 45, I'm resolving it over here, so eventually it's still facing the right. This guy, however, is going to face the left. So I can say that since right is positive and left is negative, my horizontal resultant force will be 6 cos 45 minus 4 cos 75. And my vertical, look at my vertical, if I resolve both of them to the vertical, both of them will take me down. So resolving this over here and this over here, they're both facing a downward direction. So I would have 6, you could say I would have minus 6 sine 45 minus 4 sine 75. If I put this in my calculator, 6 cos 45 minus 4 cos 75, I get 3.207 to 3 decimal places. I get 3.207, which means that my resultant force is still very much towards the right. Not exactly towards the right, like not horizontally dead right, but it is on the right quadrant, on the positive side of the x-axis, you could say it that way. And my vertical, if I put minus 6 sine 45 minus 4 sine 75, I get minus 8.106 to 2 decimal places, and I can get rid of the minus because all the minus is doing is showing me direction. And in this case, because I said down is minus, the minus means that my resultant force is towards the right but downwards. So it could be anywhere between here. Anywhere here is where my resultant force would be, which is positive on the right side but going down, so negative. Now how would I know the exact angle and the exact magnitude it's making? If I just break this down into a right angle triangle, we can agree that what I resolved, I'll just make it, what I resolved to the horizontal, this is simply 3.207, and what I got downwards was 8.106, and I want to find my resultant, which we established is, let's say, somewhere here. We don't know where exactly, but let's say it's going to go here. In order to find this, all we have to do is simply use Pythagoras theorem. So the two values you get, treat them as your a squared plus b squared and solve for your c. So I would have 3 plus 207 all squared plus 8.106 all squared equals to my c squared, which is my resultant force. And my c would be the square root of 3.207 squared plus 8.106 squared. And my c, if we just put this in our calculator, squared plus 8.106 squared, that gives me 8.72 to 3SF, so 8.72 newtons is my resultant force. 8.72. But now you also need to know the angle with what it's making with either the horizontal or the vertical axis, but most cases always try and go for the horizontal one. And for that, it's a simple formula. Just do theta is equal to tan inverse of what's in your y direction, or vertical rather, over what's in your horizontal. So our vertical we got was 8.106 and our horizontal was 3.207. And if you go ahead and do that, tan inverse of 8.106 over 3.207, that gives 68.4 degrees. So the resultant force is 8.72 newtons with an angle of 68.4 degrees to the horizontal. And the simple way how this was derived was using trigonometry. So if you want to find this angle over here, and you know that all of this is simply the same as if it's over here, So 8.106 simply use tan SOHCAHTOA. So tan of this angle here is equal to opposite 8.106 over the adjacent, which is 3.207, which is what you have here as well. That's how you basically find the resultant. On to the next one. Okay, let's take these two together, if possible. The one on the left is fairly simple. You have two of them acting on the right side mainly, so if I resolve to the horizontal first, I would have 4 cos 20. Because both of them are to the right, I can just add them because my right is positive. 4 cos 20 plus 8 cos 50. And if you go ahead and put that in your calculator, 4 cos 20 plus 8 cos 50, that gives 8.901 to 4SF. On the vertical, I would have 8 sine 50 minus 4 sine 20, because my downward directions, you're opening this up and it's going down, and down is negative for me, so 8 sine 50 minus 4 sine 20 gives me 4.760. If you use your up to be negative and down to be positive, or left to be positive and right to be negative, you still get the same answers. Just make sure you know when and where to use your exact signs. Now what this indicates is that on the vertical, eventually the resultant is upwards and it's in the right direction, right quadrants or upwards. So to find the resultant, again, just quickly do this. The resultant is square root of 8.901 squared plus 4.760 squared. If I put this in my calculator, 8.901 squared plus 4.760 squared, this gives me resultant force of 10.09 newtons to 4SF. And to find out the angle it makes with the horizontal, you can just do theta. Theta is equal to tan inverse of what was the horizontal, of what was the vertical over the horizontal. So the vertical in this case was 4.760 over the horizontal, which we had gotten eventually as 8.901, and doing this, theta is going to be equal to tan inverse 4.760 8.901, just should be around 25 or so, 28.1 degrees. So the resultant force is of 10.09 newtons, making an angle of 28.1 to the horizontal. So it would be somewhere here, in that direction. That's where the resultant would be, and it makes sense because the 8 newtons is obviously a larger force and at a higher angle than the 4 Newton force as well, so it makes sense entirely. On to the next and final example. Now this one is slightly tougher because we've got 3 different forces to consider, but it shouldn't be too hard. Again, we use the same basics. Let's start with a horizontal first. Resolving to the horizontal, I would have to begin with 3 cos 40 plus 3 cos 10, and then this guy over here is going to be closed this way, so eventually it's going to be in the left direction, which is minus, so minus 6 cos 80. So put that all in the calculator. 3 cos 40 plus 3 cos 10 minus 6 cos 80 gives me 4.21 to 3SF to 4.21. And then on the vertical, if you resolve this to vertical, I have 1 going upwards, that's positive, so that's 3 sine 40 minus 3 sine 10 because this guy is eventually going in the downward direction, and this one too in the downwards direction. So minus 3 sine 10, another minus of 6 sine of 80. So 3 sine 40 minus 3 sine 10 minus 6 sine 80. All of that gives me minus 4.50. And obviously you can get rid of the minus, but the minus does show us that it's going downwards. The resultant force is below the x-axis, so downwards, but in the positive quadrant of the on the right side rather of the y-axis, so somewhere here. Yeah, somewhere round about there, because it's going down but it's on the right side positive, so anywhere in that range. So let's go ahead and find a resultant. Again, same formula. Resultant is the square root of 4.21 squared plus 4.50 squared. R is 4.21 squared plus 4.50 squared. That is 6.16. 6.16 newtons. That's the resultant. And to find the angle it makes, we just do theta equals to tan inverse of the vertical, which was 4.50, over that of the horizontal, which was 4.21. Tan inverse 4.50 over 4.21, that is 46.9 degrees. So the resultant force is 6.16 newtons at an angle of 46.9 degrees from the horizontal, and since we had gotten a minus here, we know that it's towards downward, so it's probably somewhere here. That's where it is, because this is roundabout around 45 degrees, so 46.9 degrees. You can actually leave a minus sign. It's actually a good idea because it shows the examiner that you know that it's in the downwards direction. So yeah, that's it for the end of this video. Thank you for watching. Please do not forget to perform an LSS, that is like, share and subscribe. Thank you for watching. Have a nice one, guys.